Hello everyone, welcome to Lab 4. In this lab, we're going to do a basic motor startup procedure and discuss each step as we go through the selections. Once the motor parameters are downloaded, we will test that the motor operates in manual mode from the software. If you remember from the motor nomenclature presentation, we will need to know how to interpret the motor nameplate to be able to make the correct selections in the motor startup. That was session number 5 if you want to go back and refresh your understanding of what information is available on the nameplate. Here is an example nameplate of an older series motor that is now obsolete. This is the combined model type. DT80N4 is the motor model. BMG1HR is a mechanical brake with a hand release. ES1S is an incremental encoder. And ASB8 is a type of plug connector. Moving down the nameplate, we see that this motor is rated for 266 volts or 460 volts. This will be a delta or Y configuration depending on how the motor terminal block is bridged. Here is the rated frequency of this motor at 60 Hz. So this motor can be connected in delta for low voltage and Y for high voltage. Electrically, when we bridge the motor for delta or Y, this is what it looks like. The black bars in between the coils are the bridging connections on the terminal block. Here is an image of the motor nameplate that we will be using to do this basic motor startup. And this is the combined model type. DRN80M4 is the motor model. BE1HF is a mechanical brake with a threaded screw release. FM means that it has feet and a flange. TH is a thermostat that's built into the stator windings. And AS7W is an absolute encoder mounted on the motor. Moving down the nameplate, we see that this motor is rated for 230 or 460 volts. This will be a double Y or single Y configuration depending on how the motor terminal block is bridged. And the rated frequency of this motor is 60 Hz. Another thing the motor startup will ask us for is the rated speed. It's easy to think that this here is the rated motor speed because of the RPM unit, but this is actually not the rated motor speed. This is the continuous torque range from 300 RPM to 1800 RPM, which equates to 10 Hz to 60 Hz that the inverter can vary between. If you're wondering why the minimum speed is at 300 RPM, it's because below this speed, the cooling fan on the motor is not rotating fast enough to keep the motor within its thermal limits. If the motor needed to run continuously below this speed, it would need a forced cooling fan that is powered separately so it can force the proper amount of air over the motor to cool it. The rated speed that we would want to enter in the motor startup would be this value of 1,751 RPM. This will allow the inverter to calculate the correct slip RPM because this is an asynchronous motor. So this motor can be connected in double Y for low voltage or single Y for high voltage. The electrical configuration will look like this when changing between double Y and single Y on the motor terminal block. If you're wondering why this says star or Y under the diagram, each term has the same meaning. It will depend on who you're talking with as to what term they prefer to use. So just know that star and Y mean the same thing. From the last lab activity, you saw that there are a lot of parameters and even duplicate parameters. Those duplicate parameters are because of two different parameter sets in the MOVIDRIVE that can be switched between as needed. This also applies to the motor startup. When you go to do the startup, you have the option to start up motor parameters for set 1 or motor parameters for set 2. An example of needing two motor parameter sets could be an application that has two different motors that don't operate at the same time. To save cost and installation space, a single inverter could be used for both motors, and when it's time to switch to a different motor, the inverter can be powered down, then a contactor could be used to switch over the inverter's output to the other motor. When the inverter is powered back on, parameter set 2 can be selected with an input so it uses the correct parameters for the other motor. I want to mention that in this example, it's very important that the inverter is powered off when switching the contactor over on the inverter's output. If this is done with the inverter power switched on, it could cause a voltage arc and damage the inverter and/or the motor. Even if it's just a single motor and a single inverter application, if there is a contactor or switch that disconnects the motor leads from the inverter output, that should never be switched off or on while the inverter is powered. I showed this in the last lab activity, but you can identify the parameters for parameter set 1 or parameter set 2 based on how it's labeled. We can see here that the set point speeds for parameter set 1 are labeled N11, N12, and N13. For parameter set 2, the set point speeds are labeled N21, N22, and N23. So in this example, the first digit of the set point speed number identifies the parameter set that it's associated with. In the session 1 presentation of this training course, I went in depth with what the pulse width modulation frequency is and how that creates the AC sine waveform from the inverter. If you need to rewatch that, you can go back to session 1 to get more information about this. With the MOVIDRIVE, we can select what the clock switching frequency is for the inverter's output. For most of the MOVIDRIVE sizes, the clock frequencies are predetermined and can range from 4 kHz to 16 kHz. In the largest size 7 MOVIDRIVE, it's possible to go down to 2.5 kHz, but that will depend on the application if that's necessary. The default setting is 4 kHz, but in scenarios where you want the motor to run quieter, this clock frequency can be increased. The downside to increasing the frequency is that the MOVIDRIVE will operate hotter. So if the MOVIDRIVE is already installed in a hot environment, increasing this frequency could cause the inverter to start having thermal faults. Since this is a training environment, we will be increasing this to 16 kHz to reduce the noise that's produced with the motor running. Okay, let's head into the software and complete the motor startup for our MOVIDRIVE. Back in the software now, I have already factory reset the MOVIDRIVE, so that way we have a clean slate to start from. So to do the motor startup, I need to go into a tool to do that. So I will select the MOVIDRIVE underneath my network connection. Then I will right-click on it. I will come to the second menu item called Startup, and then I will cursor over to another second menu item called Startup Online. I'm presented with two different options. I can choose to perform startup or controller optimization. Currently, controller optimization is grayed out because I have not even went through the motor startup one time. Now, this isn't a big deal because controller optimization is a portion of the motor startup. So all this button would do is just jump to the latter half of the motor startup where we do the optimization. So I'm just going to click on Perform Startup, and then we will see the optimization as we step through the startup. Now we'll be presented with this grayed out screen where we can't select anything And the reason we can't select anything here is because it's just telling us what currently is stored in the MoviDrive. But what I can select is, do I want to start up parameter set 1 or do I want to start up parameter set 2 by clicking these tabs at the top of this window. I'm not going to be using parameter set 2 during this lab activity, so I'm just going to select parameter set 1 and then choose to start up set 1. Now I have another option that asks me, do I want to do a complete startup or a partial startup? Since I haven't done the startup, I need to make sure I choose complete. And then click next. For this lab activity, we want to do the most basic type of startup, which is going to be V/F mode, voltage over frequency. This menu item also gives me the ability to select if I had multiple identical motors connected or multiple different motors connected to a single MoviDrive. I'm not using that type of connection for this lab activity, so I'm just going to choose standalone motor, and then we'll choose the standard V/F operating mode. And then click next. Now this screen is telling me it does not detect any encoder nameplate data, and that's completely fine. Some encoders have memory in them where the electronic nameplate can be loaded to it, and then the software can read that nameplate to make the motor startup a little bit easier to go through, so that way you don't enter in any incorrect settings. But the current encoder that's connected does not have an electronic nameplate, so that's completely fine. I'll just have to enter in the motor nameplate information manually. So I'm just going to click on Next. Now this is where I need to choose the type of motor I have connected. This can be confusing if you're not familiar with the model types of our motors, but any of our older obsolete motors will be in this item for IEC. Any of our current motors would be in this item for DR. If you're using any of our asynchronous servo motors, they will be in this DRL, DR2L, CT, CV option down here. And since I chose the operating mode V/F, it's not even giving me the option to choose a permanent magnet servo motor, because you cannot run a permanent magnet servo in V/F operating mode. So that's currently grayed out. So this motor that I have connected is a DRN80M4. So I'm going to choose this second item that says SEW motor and then DR in parentheses, and then click next. All right, motor type 1 is where I will select the model type of the motor, and this is where you need to pay attention to the frequency rating on your nameplate and then also the kilowatt rating. So this motor that I have connected is a 60 Hertz only motor, and its kilowatt rating is 0.75 kilowatts. So I will choose this menu and then scroll through this menu until I find DRN80M4 for 60 Hertz and 0.75 kilowatts. Okay, we're seeing some DRN80M4 options here, but if you look in the parentheses, you can see that the frequency ratings change, but the kilowatt ratings stay the same for this size motor. Now this nameplate only has one frequency rating on it, so that's why I'm going to choose 60 Hertz. But if your nameplate had two frequency ratings, like a 50 Hertz rating and a 60 Hertz rating, you need to make sure that you choose 50/60 for your motor type selection. I don't have a 50 Hertz rating on this nameplate, so I'm just going to choose 60 Hertz / 0.75 kilowatts. The motor rated voltage for this motor is 460 volts, so I will manually type in 460. If you press enter, it'll actually jump you to the next page, so don't press enter, just type it in. The rated frequency is 60 Hertz. And then the mains rated voltage is going to be 480 volts. And then I do have an encoder on this motor, but for this first lab activity, I don't want to use it. I'm just going to ignore it. So I'm going to leave this to no encoder for right now. Now this motor does have a temperature sensor built into its winding, but it's not connected to the MoviDrive. So I'm just going to leave this selection to no sensor, since it's not even connected to the MoviDrive. And then click next. I have some options to choose speed control or DC braking. I'm not going to be using DC braking, so we're just going to do standard speed control mode. Okay, and this is one of our first optimization screens. And currently, the proposed values from what I've loaded so far in the startup are over here on this left column that's grayed out. On the right column are the current settings that are in the MOVIDRIVE. So what we recommend when you go through the startup the first time is to choose the proposed values from the startup. You can come back in and change these later, but as a beginning point to start from, we recommend using the proposed values. So an easy way to apply those proposals is just to click this Apply Proposal button. So by clicking Apply Proposal, I've proposed these values to be downloaded, but they have not yet been entered into the MOVIDRIVE until we finish the startup. So I'm going to now click Next since I've accepted the proposed values. And then now it's proposing a change of 1800 RPM. Now I didn't mention in the last screen, but anything you see in yellow is just a way for you to identify that the proposed value is different than the current value that's stored in the MOVIDRIVE. So that's why the current value that's in the MOVIDRIVE is 1500 RPM, and we're proposing a value of 1800, and it's telling me those two values do not match. So if I click Apply Proposal, it's just going to overwrite that 1500 value with 1800 RPM, which is the synchronous speed for this type of motor. So I'm going to now click on Next. Now I'm at the end of the motor startup. The basic VF mode startup is very simple. There's not many screens to choose from, and there are some basic controller parameters for this optimization. So I have two options at the end of the startup to choose from. Download will download the parameters, but then leave this startup screen open so that way I can go back and make any changes if I want to. Finish does the exact same thing as download, but it just closes the tool for me automatically. So I'm just going to click on Finish so that way it closes the tool for me since I do not need that open right now. We can always come back into the startup if we need to. And then that will download to the MOVIDRIVE. And now it tells me the startup has been completed successfully. And I'll click OK to accept that. Now, if you're looking at the lab instructions, the next thing we need to do is run this motor in manual operation to make sure that it functions correctly. So to get into manual mode, we need to select our MOVIDRIVE on the left-hand side, and then right-click on it, and then choose the item for startup, and then come down to this menu item called Manual Mode Online. Now, I do want to mention that you need to be careful with manual mode because you will have complete control of the MOVIDRIVE from your computer. So it will be your responsibility to make sure that you are controlling the motor in a safe manner. So before you click on Activate Manual Mode, you have to make sure that the machine is safe to move and that no one is around it. You should also use slow speeds so that way you have time to respond and press the stop buttons in case you're getting close to the end of travel limits with the machinery. Now I will press Activate Manual Mode, and then you will see that the 7-segment display changes its status. Okay, if you look at the 7-segment display, you see that it changed from a 1 to an H, which means hand or manual operation. Now let me show you around the features of this manual mode control screen. Up here in the top right corner is a reset button. So if the inverter were to fault, it would show the fault status here, and then you can click the reset button. It will show you the actual position of your encoder. It will show you the status of your digital inputs, and then the status of your digital outputs. This tachometer here is for the speed in positive or negative direction. And then down here is another tachometer in percentage for the output current. Moving to the center of the screen, you have the Deactivate Manual Mode button, which I will talk about in a minute. You have the Start button. You have a counterclockwise rotation, clockwise rotation, an Inhibit button, a Stop button, and then another Stop button. Now, the reason there are two different stop buttons is one has a different ramp time than the other. One of these stops is a rapid deceleration, and the other stop is just a normal deceleration. You can see this in the image here at the top. If I hover my mouse over this stop right here that has a faster deceleration than the other one, you can see down below that it's also highlighting this stop button. If I go to the normal deceleration stop, you can see that it highlights this button over here. You may also notice that I'm getting these F numbers that pop up as I go through each one of these selections, and these are the function keys of your keyboard. So the normal stop would be function 4 on your keyboard, the rapid stop would be function 5, and controller inhibit would be function 6. And you can see through these that they have different function numbers assigned to them. That way, if you want to use your function keys to change these settings, you can do that quicker than using your mouse. Okay, moving over to the left side of the screen, we have 3 different set point speeds. This will be necessary if you want to toggle between 2 speeds quickly, or if you just want to set your own speed, you can do that as well. And reference travel would perform a reference of the encoder if you had that set up. This timeout here is a communications timeout that if it loses communication with the MOVIDRIVE for this amount of seconds, it will display a timeout fault on the MOVIDRIVE. So let's test run this motor. I'm going to use the variable speed, so I'm just going to select this. If I wanted to use a different speed, then I can select those and then also manually type in a different number if I wanted to. But I'm going to choose variable, and then 15 RPM is pretty slow, so I'll choose that as well. And then now I need to choose a direction of rotation. Let's just start with clockwise. And then now, as soon as I press the start button, the motor should take off. If I need to stop it, then I can come down here with my mouse and press either one of these stops, or I can press the function key with my keyboard that matches whichever stop that I want to use. So if I press this start button, nothing happened. Do you have an idea of why nothing happened? I'm going to go ahead and press the stop button. Nothing happened because the MOVIDRIVE is still inhibited. You can see that in the status here in the top right corner. How should I clear this inhibit? If you remember from our previous discussions, I said that digital input 00 needs to remain on for the MOVIDRIVE to be clear of its inhibit. So what I need to do is go to our switch box and then switch on digital input 00. Since I've already pressed the stop button in the manual mode control screen, I know that once I clear this inhibit, the motor will not start immediately. However, if I still had the start button pressed and then cleared this inhibit, the motor would start immediately. So you do need to know if the start button is active and then you clear the inhibit afterwards, the motor will start immediately. So here is the inhibit coming on. Now you should see that the status has changed to no enable. Now if I press the start button, it will give the enable to the MOVIDRIVE to operate this motor at 15 RPM. All right, the motor is now running at 15 RPM. We can see that here on the tachometer of the actual speed. We can see the output current is currently at 23 to 24%. And then our encoder is counting. Even though we're ignoring it and not using it, we still can see the counts coming into the MOVIDRIVE from the encoder. But there is a high-pitched whine noise that we have not corrected yet. And that is the PWM clock frequency that we need to increase. So what I'm going to do is leave this running and then come over to the MOVIDRIVE and right-click on it and then go into the parameter tree. And now manual mode is still open in this tab right here in the middle, but I'm going to click back into the parameter tree tab. And I'm going to change the clock frequency of the MOVIDRIVE from its default setting. So that's in folder 8, unit functions, item 86, modulation, and then parameter 860, PWM frequency 1 for parameter set 1. So I'm going to change this from 4 kilohertz to 16 kilohertz, and let's see if you immediately notice a difference in the noise produced in the motor. Okay, I changed it to 16 kilohertz, and you should have audibly been able to notice the change in the noise produced in the motor. Another thing I want to do is come down to parameter 862, PWM fix for parameter set 1, and turn that to on. What this does is it forces the PWM clock frequency to remain at 16 kilohertz even if the temperature of the MOVIDRIVE rises. If I leave this to off, then the PWM clock frequency can automatically reduce itself if it notices the MOVIDRIVE's internal temperature is rising too high. So I'm going to leave this on because the MOVIDRIVE is in an air-conditioned training environment. Now I can close this and go back to manual mode. Now if I want to increase the speed, I can choose to drag this slider up and it will increase the speed of the motor. I can also drag that slider down. I can even type in a new number as well. So let's try 500 RPM. And then I do have to press the enter key for it to make the change. And now we're operating at 500 RPM. If I want to go the other direction, then I can just click on CCW for the counterclockwise direction. It decelerates and then starts rotating in the other direction. So if I need to stop this motor, I can either press one of the stops or press the function key on my keyboard. So what I'm going to do is move the mouse off so you can see this, and I'm going to press F4, which is this stop right here underneath the clockwise direction button. So the mouse is off, and I'm going to press F4 with the keyboard. All right, and we can see that it activated the stop on the MOVIDRIVE. Now, if I'm done with manual mode, I have to press this deactivate button to properly exit manual mode. Otherwise, it will cause a timeout fault on the MOVIDRIVE, or the MOVIDRIVE will be stuck in manual mode and it will not respond to any other commands until you deactivate it from manual mode. So what I need to do first is put it into an inhibit state, because currently we are at no enable. So I'm going to go to the switch box and then activate the inhibit by turning off digital input 00. Digital input 00 is now off, and we can see that it shows controller inhibit. Now the MOVIDRIVE is in a state where it will allow me to deactivate. So now I will come to deactivate and then press that. It's giving me a warning telling me that the computer is now releasing control of the MOVIDRIVE, and it will take back on to its normal control either from a PLC or from its terminals. So even when you go to deactivate manual mode, you need to understand that it is possible for the machinery and the motor to automatically move as soon as you give control back to the PLC or to its terminals. I'm not using anything that's going to control this externally right now, so I'm just going to click the yes button to deactivate manual mode. Okay, and now we're out of manual mode, and you can see that we're back to the beginning screen where it lets me select activate. That's one way to confirm that we are out of manual mode. And the other way to confirm that we're out of manual mode is we can see now that the 7-segment display has changed from an H back to a 1, which means inhibit. Okay, this is the end of our 4th lab, and we went through how to do a basic motor startup with the nameplate parameters, and then also how to confirm that the motor is functioning correctly with manual operation, and then some rules about how to use manual mode with the MotionStudio software. In the next lab, we will go more in depth with terminal control mode, and we will use our switch box to control the MOVIDRIVE instead of using manual operation. Thank you for your attention. Take care and have a good day.